This tutorial accompanies assignment 1 for Stat 121. In it, I will demonstrate how to use Matlab to load data from an external CSV file into an array, compute various descriptive statistics on that data, and then construct two statistical visualizations of the data. We begin by loading our external data into an array in Matlab. The external data is stored in the file dataexample.csv, and we use the CSV read function to access it. All we have to do is apply the CSV read function to the name of that file. Then we store the output of that function in a variable called data. If you were to look at our actual data file by opening it in a spreadsheet or a similar program, you would see that it just is arranged as a single column of 40 numerical values. Now we'll begin computing some basic descriptive statistics of our data. Since that data is stored in the variable that we've named data, we can accomplish this task by applying various Matlab functions to that variable. For example, we can compute the minimum and maximum values of the data set using the min and max function. We can compute the mean, the median, and the mode of our data set with the mean, median, and mode functions. For each of these computations, we've created a new variable, capital minimum, maximum, mean, median, and mode, to capture the values computed by these functions. We'll continue computing descriptive statistics of our data set by finding its quartiles. Matlab has a function called quantile that can calculate quartiles, but it can also calculate more general quantiles broken up over any range of percentages. To cause this to compute the quartiles of our data, we've got to tell the function about our data set. So that's the first input variable that we supply as the name of the variable containing our data set, data in this case. And then we need to give it an array of separators, separating the interval from 0 to 1 into the quantiles that we want. Since we are computing quartiles, our separators are going to be 0.25, 0.5, and 0.75. However, if we had wanted to calculate the percentiles in tenths, or 10 percentage point steps, then this range would have been 0.1, 0.2, 0.3, all the way up to 0.9. As before, we've set up a variable to capture the output of this computation, and in this case that variable is Q. Next, we'll calculate the population variance and population standard deviation of our data set. This can be accomplished using the var and the std functions of Matlab and apply them to our data set variable data. But since we're calculating population variance and population standard deviation, these are the uncorrected or the biased versions of that statistic. And we indicate that that's what we want to compute by supplying a separate input of 1 for each of these computations. And again, we've captured the output of these computations with variables called population variance and population standard dev. Our final two descriptive statistics that we'll compute are the skewness and kurtosis of our data set. And Matlab contains a skewness function and a kurtosis function that can be applied to our variable containing the data. We store the results of these two computations in variables called skewness and kurtosis. If you execute a Matlab script that has that same sequence of commands that we just saw, then you should see output that looks something like what's displayed on the screen right now, where the values of all of the variables that we've created are displayed, showing the results of all of our descriptive statistic computations. Next, we'll construct two visualizations of our data set. The first of these will be a histogram, and I'll go through line by line the code required to accomplish this. I begin by creating a standalone figure window to capture the histogram using the figure command. Then I use the histogram command to make the histogram itself. I supply this command with two inputs. The first is the array containing our data, and the name of that array, or the variable, was data. And then the second was a specification of the edges for the bins in our histogram. I wanted my bins to be 1 unit wide with their centers placed over each of the integer values that are visible in our data set. This meant I wanted to cover a range from 0 to 30. So my edges were going to range from negative 0.5 to 30.5 in the default step of 1. Once the histogram was created, I customized it by providing a title of histogram, a label along the x-axis using the xlabel command, and a label along the y-axis using the ylabel command. I also specified that there should be a tick mark along the x-axis at each integer starting at 0, going in steps of 1 up to 30. And then finally I used the grid command to overlay what looks like graph paper on my histogram. If that code fragment appears in a script that you run in Matlab, it should produce a figure window that contains a graph that looks something like what's displayed on the screen right now. We can see that it's just a standard histogram with bin widths of 1, and the heights represent the number of times an observation with that value has appeared in our data set. The next visualization I'll produce is a box and whisker plot. To accomplish this, I set up a second figure window using the figure command again, and then I simply apply the box plot command to our data variable. I do go ahead and customize this plot a little bit by adding a title to it using the title command as well. And once again, if that code fragment appears in a Matlab script that you've run, it should produce a second figure window that contains a box plot looking something like the one that is showing up on your screen right now. Remember, the box plot displays the location of the median of your data set with the horizontal red line, the first and third quartiles with the horizontal blue lines or edges of the box, and then the min and the max of the data set with the horizontal black whiskers. By default, Matlab will also detect outliers and represent those with a little red plus sign out beyond the whiskers, but this data set did not have any outliers.